All right, now that we know how to graph a parabola in set form, we're going to look at an example. All right, so our first example is going to be y equals 2x squared plus 4x minus 1. Okay, so we're just going to follow steps we learned. 1, find the vertex, and then 2, plot a couple of points. So step 1, find the vertex. Well, we know the vertex is going to be at negative b over 2a. Now, what's b, what's a? So it's helpful to kind of go back and remind ourselves what a and b and c are. And remember that in standard form, this is ax squared plus bx plus c. We talked about that when we were factoring trinomials as well. And so we could see that a is going to be the coefficient in front of x squared, b is the coefficient in front of 4, and c is everything that doesn't have an x. So a is equal to 2, b is equal to 4, and c is equal to negative 1. It's helpful to identify your a, b, and c. And so now coming back to the x value of the vertex, x is going to be negative b, so that's negative 4 over 2a, so a is 2, and so it's 2 times 2. So negative 4 over 4 is going to give us negative 1. All right, so now we have the x value of the vertex, so we did this right here. And now we need the y value of the vertex, and we find it by plugging the x value back into the equation. So we did step 1. Now let's do, well, we did half of step 1. Let's do the second half of step 1. So y is going to equal, now we plug in a negative 1 for x, so negative 1 squared plus 4 times negative 1 minus 1. So we see what we're doing is everywhere you have an x, we're replacing it with negative 1. So now this is where the order of operations comes in handy, because if you don't know your order of operations, you're not going to be able to evaluate this correctly. We get 2, you do exponents first, 2 times 1. And then after exponents, we do multiplication. And we just can go to left to right for multiplications. We get 2 minus 4 minus 1. And then finally, we do addition, subtraction, going left to right. 2 minus 4 is negative 2. Negative 2 minus 1 is negative 3. So our vertex is going to be at the spot negative 1, negative 3. Okay, so we found the vertex. We did step 1. So negative 1, negative 3. Here's our vertex. All right, so that's step 1. Step 2, plot a couple points. Okay. So how many points do we need? Well, it depends how accurate you want to be. So every single parabola is going to have a line of symmetry. So I'm going to draw a little green line going down, and that's helpful because then we only have to plot half as many points. If you go up to all these other ones that we did earlier, you'll see that there is a green line we could draw right through the vertex. And even though my sketches are a little sketchy, you can see what I'm trying to do, and I'm trying to show some symmetry there. And the idea is if I folded my paper about the dotted line, the left and right side should match up. If I folded my paper about the dotted line, the left and right side should match up. That's called symmetry. So we have symmetry with parabolas. All parabolas have symmetry, which means we don't have to plot as many points. We can just plot in a point on one side, and then we know the point on the other side. So if the vertex is at x equals negative 1, then what might make a lot of sense is to plot a point at 0. So what we're going to do now is plot some points. And so we can say, here's our x, here's our y. What happens if x is equal to 0? So let's figure that out. And I guess I'll show my work over here. So our equation is y equals 2x squared plus 4x minus 1. Okay, so if I plug in 0, so x equals 0, I'm going to get y equals 2 times 0 squared plus 4 times 0 minus 1. Well, this is 0, this is 0. All you have is negative 1. So when x equals 0, y is equal to negative 1. So when x is equal to 0, y is equal to negative 1. But because we have symmetry, we can say, all right, if I went 1 to the right, I'm going to be at y equals negative 1. Also, if I go 1 to the left, I should be at y equals -1. That's part of the symmetry. So that means when x is equal to -1, -2, when x is equal to -2, we should also get -1. I mean, you could test it by plugging in and see if it's true, but it should be true. And we don't have to test it because we know we have symmetry. So now we went one place to the right, which gave us the same value when we go one place to the left. So let's go two places to the right now. Let's test out x equals 1. So if we test out x equals 1, we're going to get y is equal to 2 times 1 squared plus 4 times 1 minus 1. And so again, following our, I'm not going to do all that in my head. That's a little too much probably. So following our order of operations, 1 times 2 is 2, 2 plus 4 minus 1, 2 plus 4 is 6, minus 1 is 5. So 1 is going to give us 5. So that means if I go over to x equals 1, go all the way up to y equals 5. That's going up fast, isn't it? All right. In the same way, if I went 2 to the right, I should be able to go 2 to the left, which is going to be at -3. By going to the left, I should go up to the same spot, which is y equals 5. Okay, and that gives us a pretty good idea of what our parabola looks like. And we have several points to go through there, like something like that. All right, and the more accurate you want to be, the more points you can plot. But you get the idea, the process of plotting a parabola, creating a graph from parabola, which is based on A, find the vertex, and B, plotting points. So that's basically how you do it. And so go ahead and write a 2 or 3 sentence summary. And thanks for listening, and thanks for learning.